Previously, we discussed how to calculate molarity as a unit for calculating solution concentrations. There are other units that we use sometimes. So molarity is the most common, but there are a few others that you need to be familiar with. So the 5 that we're going to talk about are mass percent, volume percent, mass volume percent, and then parts per million and parts per billion. So we're going to go through the definitions for each of these, and then we'll do a few practice problems with them. Mass percent is calculated as the mass of the component divided by the mass of the solution. So this is the total mass of the solution, and we take the mass of whatever component we're interested in and divide that by the total mass of the solution. Volume percent is very similar. Volume percent is the volume of the solute divided by the volume of the whole solution. So we would take whatever is dissolved in our solution and divide the volume of that by the volume of the entire solution. Mass volume percent mixes those two. We take the solute's mass divided by the solution's volume, and we express that as a percentage. So there's a few instances where this is common. For example, in the medical field, for some types of intravenous fluids, for things like saline solutions, they typically express them as mass volume percents. So for example, a saline solution that has a 0.9 mass volume percent means that we have 0.9 grams of solute per 100 milliliters of solution. And remember, percent is per 100, so that's how we know that we have 100 milliliters of solution. Typically, we will abbreviate mass volume percent as M over V. Now, parts per million and parts per billion have very similar definitions. The only difference is the exponent. Parts per million is the mass of the solute divided by the mass of the solution times 10 to the 6th. Parts per billion is the mass of the solute divided by the mass of the solution times 10 to the 9th. So let's look at a few examples and calculate some concentrations here. A saline solution is prepared by dissolving 0.25 grams of sodium chloride in water to make 1.50 liters of solution. We're going to assume the density of the solution is 1 gram per milliliter. So we want to calculate the molarity and the mass percent of the saline solution. So to start with, if we're going to calculate molarity, we know molarity is moles per liter, which means that we've got to calculate moles. So 0.25 grams and if you add up the molar mass of sodium chloride, that comes out to 58.44 grams of sodium chloride per 1 mole of sodium chloride. So 0.25 divided by 58.44 comes out to to calculate molarity, we take the 0.0043 moles that we just calculated divided by 1.50 liters. And if we divide that out, we come out with 0.0029 molar sodium chloride. Now to calculate the mass percent, we have to convert liters into grams. And we're given the density of the solution. We're assuming it's 1 gram per milliliter. So if we start with 1.50 liters, we know that there are 1,000 milliliters in a liter. And then for every 1 milliliter, we have 1 gram of solution. So 1.50 times 1,000 gives us 1,500 grams of solution. So the mass percent, and I'm going to have to write this up top here because I'm running out of room. We take the 0.25 grams of sodium chloride that we have, and we divide by 1,500 grams of solution. And then we need to multiply that answer by 100 to make it a percentage. That comes out to 0.017%. So let's look at another example here. We have a solution that's prepared by mixing 1 gram of ethanol with 100 grams of water to give us a final volume of 101 milliliters. And we're told that the density of ethanol is 0.789 grams per milliliter. So we want to calculate the molarity, mass percent, volume percent, and mass volume percent of the solution. So I'm running out of room here, so I'm going to add an extra slide so that I will have space to write all of this in. So let's start with molarity. We have 1 gram of ethanol, and we need moles of ethanol and liters of solution. So if we have 1 gram of ethanol to start with, if you calculate the molar mass of ethanol, 2 carbons actually is a total of 6 hydrogens, not 5, because there's one over here, so 6 hydrogens and 1 oxygen. That comes out to 46.08 grams of ethanol. So 1 divided by 46.08 comes out to 101 milliliters divided by 1,000 will give us 0.101 liters. So if we divide that out, we come out with 0.215 molar. So now we've got molarity done. So let's calculate the mass percent. So we're told that we have 1 gram of ethanol, and we had 100 grams of water. Now remember, mass percent is mass of solute divided by mass of the solution. So we can't just do the 100 grams of water. We have to add the gram of ethanol as well, because we need the total mass of the solution. So we're going to have 1 gram divided by 100 plus 1 is 101 grams. So if we divide 1 divided by 100 and then multiply that by 100 to make it a percent, 1 divided by 101, and then we multiply that by 100 to make it a percent, we get 0.990%. So that gives us mass percent. Now we want volume percent. So for volume percent, we have the volume of the solution, but we need the volume of ethanol. So we have to convert the 1 gram of ethanol to milliliters, and we're told that the density of ethanol is 0.789 grams per milliliter. So since I'm starting with grams, I'm going to put grams on the bottom. So 1 divided by 0.789 gives me 1.27 milliliters. And I'm not going to circle that yet because it's not my final answer for volume percent. To calculate the volume percent, I'm going to take 1.27 milliliters, which is the volume of ethanol, divided by the 101 milliliters of solution, and multiply it by 100 to make it a percentage. So that gives us 1.25%. So the last thing that we want to calculate is the mass volume percent. And luckily for us, we already have the mass of ethanol and the volume of solution. Let's go with an orange color. So we can abbreviate mass volume percent as M over V. So the mass of ethanol is 1 gram, and the volume of the solution is 101 milliliters. So if we divide 1 by 101 and then multiply by 100 to make it a percentage, that comes out to 0.990. Okay, one more example here. Suppose a 155.3 gram sample of pond water is found to have 1.7 times 10 to the negative 4th grams of phosphates. What is the concentration of phosphates in parts per million and parts per billion? So for parts per million, we take the mass of solute per the mass of solution and multiply by 10 to the 6th. So our mass of solute is 1.7 times 10 to the negative 4th grams. And the mass of our solution is 155.3 grams. So if we take 1.7 times 10 to the negative 4th divided by 155.3, and we multiply that by 10 to the 6th, we get 1.1 parts per million. For parts per billion, we're going to do the exact same thing, except that we're going to multiply by 10 to the 9th. So we're going to take 1.7 times 10 to the negative 4th grams, divide it by 1.7 and if we multiply that by 10 to the 9th, we get 1,100 parts per billion. So this is all the concentration units. So we're going to get some more practice with this in class. So I will see you in class.